right, where's the beginning? The beginning is right here. Perfect, perfect. Welcome, ladies and gentlemen, to part B of the 2013 multiple choice AP Calculus AB practice test. For this section, we're going to be using the calculator, but I actually don't have one with me. So that means that in some of the questions, I'm not going to be able to finish him, but at least I'll give you my strategies and what I would do if I did have a calculator with me. And yeah, it's going to be up to you guys to finish solving the problem. So number 76. The graph of the function f is shown above. It has two line segments and a semicircle. What is the value of g of 5? Okay, so if I want to find the g of 5, we're going to go ahead and plug it into the equation given to us. G of 5 is the integral from 0 to 5 of f of t dt. Notice how we start at 0. And if I start at 0, we're going to be finding the area of a triangle and a semicircle. So we have 1/2 base times height plus 1/2 pi r squared. The base of the triangle is 1 and the height is 3. And for the circle, the radius is, well, the diameter is 4, so the radius is 2. Okay, this gives us 3/2 plus 4 times 1/2 is 2, so 2 pi. So there it is. We have 3/2 plus 2 pi. Okay, D. Number 77. The volume of a sphere is decreasing at a constant rate of 3 cubic centimeters per second. All right, let's make a note of that. dV dt equals negative 3 cubic centimeters per second. At the instant when the radius of the sphere is decreasing at a rate of 0.25 centimeters per second, okay, that's another rate. So dr dt equals negative 0.25 centimeters per second. What is the radius of the sphere? Okay, oh, and they give us the volume of the sphere. That's great. So let's go ahead and find the derivative for that. dV dt equals 4/3 times 3 pi r squared. And we're going to have to use the chain rule right here. So we get times dr dt. Plug in the rate of the volume. The radius is what we're looking for. So r squared times negative 0.25. All right, let's go ahead and solve for r. 4 times negative 0.25 is negative 1. Divide by a negative. Divide by pi. And square root it. All right, so there it is. There's the first answer that I'm not going to be able to do because I don't have my calculator with me. But you guys do. So go ahead and figure it out. 78. Let f and g be continuous functions such that those integrals are true. Okay, what is the value of the integral from 0 to 3? Let's see, where can we start? So we have an integral for f from 0 to 10. We have an integral from 0 to 10 for g. All right. So here's what I'm going to start by doing. Let's see. The integral from 0 to 10 for f of x dx plus the integral from 0 to 10 no, let me adjust this one. This one right here is going to be the integral from 0 to 10. We can take the 1/2 to the outside. We know it's equal to 8. So if I multiply both sides by 2, we get a 16. So now we can say the integral from 0 to 10 of g of x dx equals 21 plus 16. So if you combine them, the integral from 0 to 10 of f of x plus g of x dx equals 37. Okay. So now right here, I'm going to go ahead and take this current integral that we have, the integral from 0 to 10 of f of x plus g of x dx. And I'm going to take this other integral that's given to us, and I'm going to go ahead and flip that. So minus the integral from 10 to 3 of f of x minus g of x dx. So we already established that the first integral that we created was 37 minus the integral in green is 2, right? Just don't forget that we have a subtraction sign right there. Oh, and this, I'm not getting this one because I'm going to get 35 right now. Let's see. Let me look at my work. Okay, let me backtrace real quick and go back to the beginning right here. I'm going to try a slightly different setup. Let's say we have the integral from 0 to 3 of f of x minus g of x. Oh, that's the reason, because it's a subtraction and we have a plus. Yep. I see that. Let's go back to this right here. We need to subtract these guys. So the integral from 0 to 10 of f of x dx minus the integral of g f of x. Let me see where we left off here. That was 21 minus the integral from 0 to 10 for g. That's 16. So that means the integral from 0 to 10 of f of x minus g of x is 5. Okay, keeping this. Let's see if this is going to work out now. So let's see. I'm going to go ahead and set it up like this. The integral from 0 to 3 of f of x minus g of x, that's the one that we're looking for, plus the integral from 3 to 10 of f of x minus g of x dx, that's the one that we circled in right here. Now the first one's the one that we're looking for. I'm just going to shorthand it and say f minus g. The second integral from 3 to 10 of f minus g, that's a 2. And it's going to equal the integral from 0 to 10 of f minus g, that's a 5. That's the one that we just figured out. And if I subtract the 2 from both sides, we get 3. There we go. I don't have the answers with me, so I'm hoping that that's the answer, but I feel pretty good about it. 79. The figure above shows the graph of f prime, the derivative of the function. Okay. If f of 0 equals 0, which of the following of the graph could be the graph of f? Okay, so here we're given an initial condition. We're saying that the point 0, 0 is on the graph. And if I look at my 5 choices, well, there you have the point 0, 0. Okay. If we look at the derivative, we can see that from 0 to 2, the derivative is positive, which means that f is increasing on 0 to 2. But then from 2 to 3, the derivative dips underneath the x-axis, so f is decreasing on 2 to 3. And once again, f is increasing from 3 to 4. Okay, so let's see. We're looking for a graph that's increasing from 0 to 2. A is A is gone because it starts to decrease right here. B is also gone because it starts to decrease at x equals 1. E is disqualified because it starts to decrease from 1. So that leaves us with 2 choices. So let's take a look. F has to be decreasing from 2 to 3. So this one checks off that requirement. From 2 to 3. This one also checks it off. And last but not least, increasing from 3 to 4. They are both increasing from 3 to 4. But if you look at your endpoint, the derivative shows us that at x equals 4, the derivative is 0. So f prime is equal to 0, which means the slope is 0. If we look at our choices C and D, the slope right here does not look like it's 0, right? But if you look at the other one, we're starting to approximate that tangent line, a horizontal tangent line where the slope is 0. So I'm going to go with C right here. And you know what? We can even analyze it a little further. Let's go back and look at the derivative. The value of the derivative is positive from 0 to 2, but also, if you look at the graph slowly, the slope is getting steeper, 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 because the slope values are increasing, right? Once we get to x equals 1, the value of the slope, it's the highest. Whatever this represents right here, it's the highest value. And then after that, the slope, still positive, but now it's smaller and smaller until it hits 0. So the slope gets steeper at x equals 1. It peaks, and then the slope is still positive, but it gets smaller. And that's actually what you're seeing in C, right? Look at the slope right here. The slope is positive, positive, positive. Right here, the slope is the steepest. And then the slope starts to like flatten out, flatten out, flatten out. And you don't see that in the other one. So I'm going to go with C. For time t is greater than or equal to 0, the position of the particle travels along a line given by a differentiable function s. And then s is decreasing for t is greater than 2. Which of the following is the total distance of the particle travels? Okay. Well, total distance traveled, we can simply take the integral from 0 to 5 and take that the absolute value of s of t dt would give us the total distance traveled. The position of the particle traveling along the line is given by a differentiable function s. If s is increasing from 0 to 2 and s is decreasing from t to 2, which of the following is the total distance traveled? Well, because all the options use a derivative, I'm going to go with the formula that we established. I'm going to say that it's E. Whoa, what just happened? There we go. Okay. 81. A cup of tea is cooling in a room that has a constant temperature of 70 degrees Fahrenheit. If the initial temperature of the tea at 0 is 200 degrees Fahrenheit, okay, initial condition, 0, 200 degrees, and the temperature of the tea changes at the rate given by R of t, what is the temperature to the nearest degree of the tea after 4 minutes? Okay, so we're going to use the formula f of x is the integral from 0 to x of f prime of t dt. plus f of a. So if I want to find the temperature of the T after 4 minutes, we're going to say the integral from 0 to 4 of r of t dt plus my initial condition, which is 200 degrees Fahrenheit. You're going to plug that into the calculator and you're going to get one of these answers. Okay. The derivative of f is given. At which of the following values of x does f have a relative maximum? So I definitely need the calculator for this. What I'm going to do is I would graph f prime of x. So you're going to graph it in your calculator, right? And I'm just going to go ahead and make up a graph to tell you what's going to happen. Let's say the graph looks a little something like this. So because we graphed the derivative, you want to find, first of all, the x-intercepts. And again, this graph is completely made up. I'm just using the fact that it's a cubic function, but it's probably going to look completely different. So you find your x-intercepts. You do your second trace 0. You find your x-intercepts, which I'm going to call A, B, and C. And then you want to analyze your x-intercepts. You want f prime to go from positive to negative, and that would represent a relative maximum. You go from increasing to decreasing. So in this case, B would be my point, my relative maximum. On the interval from negative 2.5 to 2.5, okay, so they're telling you what window to use on the graphing calculator. That way you can actually focus on the correct x-intercepts. And yeah, that was just my example. So go ahead and figure it out. The table above gives the selected values for a continuous function. F is increasing over the closed interval from 0 to 3. Okay, F is increasing. Which of the following could be the value from 0 to 3? F is increasing, which means F is not decreasing. So the values that we don't see, for example, between 0 and 0.5, this value would have to be less than 4. It could be anywhere between 0 point something all the way to 3.99999. But it can't be anything higher than 4 since F is increasing. So what's the integral from 0 to 3? So here's a visual representation of what we have. We're going to start with the point 0, 0. We're going to end with the point 3, 54. And no matter what it's doing, it has to be increasing. That could be with a straight line. It could be with a curve whose concavity is positive. It could be with a curve whose concavity is negative. So which of the following could be the integral from 0 to 3? Well, why don't we start with a triangle? The y value here is 54. So the integral from 0 to 3 would be 1/2 base times height. And that would be 27 times 3. I should have had my calculator here, but this is 81. Okay. If it's increasing over the interval, which of the following could be the value? 4. Let's check something real quick here. Let's see the growth. That's a +6. That's a +4, +6, +8, +10, +12, +14. Okay. So that tells me it's going to have a, see the slope? The second derivative here is plus 2. So that tells me the graph is going to be concave up, at least from the selected values that I got. And if the triangle gave me 81, we're going to have to subtract this area to get the value. But then right here, that's going to eliminate D and E, leaving us with 3 lower choices than 81. Let's give another attempt at this. We're going to try to use MRAM, because MRAM would be the closest approximation to this. And I'm going to use the interval from 0 to 1. The height would be the middle from 0 to 1, which is f of 0.5. You know what? Let me show my work. Plus from 1 to 2 times the height, which would be f of 1.5, plus from 2 to 3 times the height of 2.5. So here we have 1 times 4 plus 1 times 18 plus 1 times 40. 4 plus 18 plus 40, that's 58, that's 62. So MRAM gives us 62. I'll go with that one. The graph of a function f is shown in the figure above. Which of the following statements is true? F is continuous at x equals a. Nope, because there's a removable discontinuity. Right, there's a hole. The limit of 6 approaches a is equal to 1. No, the limit is actually equal to 2, because as you get closer and closer to x equals a, from the left side and the right side, we're getting really, really close to the hole, which is 2. Well, that's actually what we talked about with D. So yeah, the limit as x approaches a is 2. The limit does not exist, that it's false. We just said that the limit is equal to 2. F of a is equal to 2. It's false. F of a is actually equal to 1. That's where the function is defined. A particle moves along the x-axis. Its position is given by x of t. What's the velocity? At the first instance, the particle is at the origin. Well, go ahead and find the derivative. If the derivative of x of t is given by a negative sign of the square root of t times the derivative of the square root of t. And if you want to simplify that, that gives us negative sign of the square root of t divided by 2. The particle moves on the x-axis so that its position is given by x of t. What is the velocity of the particle? At the first instance, the particle is at the origin. Well, if I plug in x is equal to 0, we're going to find the initial position. The position of the particle is 1. So at what time is the particle at the origin? So in other words, at what time is the y value 0? So why don't we make x of t is equal to 0. So now cosine of the square root of t is equal to 0. Take the cosine inverse. When does cosine equal to 0? At pi over 2, at 3 pi over 2, 5 pi over 2. And then we're gonna square it. So at pi squared over 4, 9 pi squared over 4, and 25 pi squared over 4. But the first time that the position is 0 would be pi squared over 4. So then you take your derivative and you plug it in. And you know what? You don't even have to do that derivative by hand. You can always just use the calculator and use math 8. Just in case the derivative is pretty complicated to compute. But since I already did it, I'm just going to show that I'm going to plug it in. And then whatever that gives you, then that's the velocity of the particle. The first instance, the particle's at the origin. I don't know what it is, but it's got to be one of those answers. And again, you don't have to do it by hand. Once you find your t is equal to pi squared over 4, you would just use math 8. So you can find the derivative of x at, the calculator is going to use x, right? So at x is equal to pi squared over 4, and then you plug in your function, your cosine of the square root of t. Okay. 6. The derivative is positive. The second derivative is negative. Which of the following could be the table for f? Okay, so that means this is a slope. The slope has to be positive. Let's find those differences. Here we have -1, -2. The slope is negative, so that's gone. 0, 0. Looks like it's gone. +1, +1. That checks off. +1, +2. +2, +1. So the first derivative is positive for C, D, and E. But then the second derivative has to be negative. So here the second derivative is 0. The second derivative is 0. The second derivative is +1. And here it's -1. So it looks like we have a winner. F is the function with first derivative. How many relative extrema does f have on the open interval? So you guys are going to have to graph it. So graph your derivative. And again, from -4 to 2, you're going to have to, it's be best if you change your window. No, my graph is going to look really bad here. Let's fix this. So whatever the graph is doing, make sure that you're actually crossing the x-axis. Because if you don't cross it, it doesn't count as a relative extrema. So in this random graph that I created, again, completely random, I would have a relative maximum here. This one is a critical point, but it's not a max or a min. This would be a relative minimum. And then this would be neither. So in this case, it would be 2 in my random example, right? But that doesn't mean the answer is 2. So you're going to have to graph it yourselves. The graph is twice differentiable. Okay, which of the following is true? Looking at my choices, I have a lot of f prime, which means this is the slope, right? So f prime of -1. It looks like f prime of -1 is 0. Because the slope is 0. F prime of 0. The tangent line is positive, so f prime of 0 is positive. And then we have f prime of 1. The tangent line is negative, So that means the derivative, that's a positive one, is negative. So f prime of 1 goes last. Then f prime of negative 1. And finally f prime of 0. So there it is. What is the volume of the solid generated when the region bounded by the graph of x and the lines x equals 0 and y is equal to 5 is revolving about the y-axis? So if I want to graph this equation, we're going to have to maybe solve for y. X squared plus 2 is equal to y. So the y-intercept would be 2. It's a positive quadratic, so it's going to go like that. And this region is bounded by the lines x equals 0 and the line y equals 5. So it's going to be this region. And you want to revolve it with respect to the y-axis. So we're going to do a mirror image, right? It's going to be reflected. So we're doing a revolution, pi r squared. We're going to do the integral from a to b. Because it's one revolution and there's no gaps, it's just pi r squared dy. So the integral from 2 to 5, the radius right minus left. The radius is right minus left. So if you look at the radius, we have the function minus 0. And the function has to be in terms of y. So the square root of y minus 2 squared dy. And even though this one is pretty simple enough, I'm not going to go into it by hand. We could. The square root and the square cancel each other out. But just go ahead and plug it into the calculator. The population of a city grows according to the differential equation. K is a constant. T is measured in years. If the population doubles every 12 years, what is the value of K? Well, we're gonna try to do a separation of variables here. I'm gonna go ahead and divide by P, and I'm also gonna multiply by dt. Let's see if this works. So we get the ln of P equals kt plus c. Take E, use it on both sides. And the population doubles every year, every 12 years. What is K? But we were not given an initial condition. So there's this lesson in chapter 7 that we skipped about this. I saved it for BC. And I'm thinking we're going to have to use that. Because right now, using separation of variables, I don't see how we're going to be able to solve this. We don't have an initial condition. We just know that it grows every 12 years. So I think I'm going to have to show you that in class. Okay. A chapter 7 lesson that we skipped. See, and if you, a question like this might be pretty rare. We skipped it. We saved it for BC because you're not going to get many questions like this. And even if you do, it's only one question. So, I mean, it's not something to stress about. So I'll show it to you in class. The function, if it's continuous, what is the value of the integral? Okay. So notice how we have a u right here. We're going to have to do u substitution. So u is going to be x squared minus 1. The u is going to be 2x dx. And if you divide it, we get 1 over 2x du is equal to dx. We are also going to change our limits of integration, but I'm going to do that in a bit. The integral from 1 to 3 of x f of u times 1 over 2x du. Dx is cancelled. And you know what? Let's go ahead and change the limits of integration now. If I take my 3 and I plug it in, I'm going to get 3 squared minus 1. I'm using this formula again, which is 8. And if I plug in 0, I get... Oh, no, I'm not supposed to plug in 0. 0 is what I'm going to get. Sorry. I'm supposed to plug in 1. 1 squared minus 1 is equal to 0. So my limits of integration are 0 to 8, f of u du. And because we're already told what the integral from 0 to 8 is, it's 6. That means this is going to be 1/2 times 6, which is 3. 92. The function f is defined for all x on the closed interval if f does not attain a maximum value, which of the following must be true. Okay. F is defined for all x values, which means there is no discontinuities. Or there could be a jump discontinuity, but there would be no infinite discontinuities. F is not continuous. F is not bounded. F does not attain a minimum value. The graph of f has a vertical asymptote. The derivative equals 0 does not have a solution. Okay. Well, we know the function f is defined for all x in the closed interval from a to b. Let's start with the vertical asymptote one. If the graph from a to b has a vertical asymptote, let's say it looks like this. Vertical asymptote, then the function wouldn't even be defined. The function right here, well, the vertical asymptote itself is an undefined value, so can't be that one. The equation f prime of x is equal to 0 does not have a solution. But with e, you can have a corner, and that could be your maximum. And f prime of x is equal to 0 doesn't have a solution, so that's not going to be it. F does not attain a minimum? No, you can have a minimum without having a maximum. F is not bounded. If it's not bounded, that means it's going to infinity. Let me see, from A to B. So that means there were going to be a max or a min. So maybe something like this. But we're saying we have a closed interval, and and the function f is defined. So the function should be, if we say f of a, we should actually get a number, a value. And infinity is not a value, so I don't think that's it. F is not continuous. That would be the only option that I can think of makes sense. If you go from A to B, you can have something that's an open circle, and then it's a closed circle right below it. And let's say it has another point right here. Just gonna make it simple like that. Technically, this doesn't have a maximum because the highest point would be the open circle. But since it's not defined, you can pick a point closer and closer and closer to the open circle, but there's always one higher, right? And since the actual open circle is not defined, you don't have a maximum. So I'm going to say A. Okay. I did not check my answers, so hopefully we got most of them right. There is one question that I skipped, and I'm going to do with you guys in class. The one about the population, number 9. Okay. And I'm not even worried about that one, about the lesson that I skipped, because this is like the first question I've seen pop up in all the exams I've given you. So we might not even do it. But check your answers, check my answers, por favor, and I'll see you then. Hasta luego.